You're listening to a Pop House Network podcast for developers by developers. Welcome to Java Pop House episode 104. Hey everyone, my name is Freddie Guime, and I am here, with another episode of our Pop House. This is a fun one because we're gonna go, gonna kind of like pull the curtain a little bit on AI and go to see like the real inner workings, maybe a little bit of how the sausage is really made, on like how these systems do work and how do we consume them. So it's gonna be a very, very fun episode because we have a guest speaker. Renee, for those who are tuning in for the first time, my name is Freddie Guime. I am one of the distinguished engineers at Expedia Group. Speaker, author, Java champion, and Seattle Java Users Group, co-organizer. And I'm here with my usual suspect, Bob.
Hey everybody, Bob Paulin, former independent consultant and now a Data Volo engineer. So employed for the first time in 12 years. So that's interesting change for me. Java champion, Apache Software Foundation member, CJUG board chair, and speaker. We'll be at Dev Nexus. So if you're around, this will probably be released after that. But come say hi to us.
Yeah, and as part of this, we have our guest Tim.
Yes, thank you. I'm thrilled to be here. Tim Allison, chair of Apache Tika on a bunch of other Apache projects. I love files and search.
Which is very, very hot right now, right? So
mostly the search part. People are starting to realize that files are also important, especially with the with the advent of LLMs and stuff. More later.
Yeah,
I don't want to get ahead of myself.
All right. Before we start, I wanted to thank our sponsors. Today's show is sponsored by Datadog, a monitoring and analytics platform that integrates with over 450 technologies, including AWS services, Docker, and Kubernetes. Datadog's platform brings together metrics, traces, and logs in one place, so you can get full visibility in your environment and improve your application performance. With machine learning-based alerts, customizable dashboards, and distributed tracing, Datadog makes it easy to unify disparate data sources so you can troubleshoot faster. Start your free Datadog trial today. Listeners of this podcast will receive a free t-shirt once you install the agent and create one dashboard. Visit javapophouse.com/Datadog to get started. Again, the URL is javapophouse.com/Datadog. And we thank them for sponsoring us and essentially keeping the mics on and the beers flowing. So definitely, great system. Go give them a try. We use them all the time, and it's a lifesaver. So yeah, go check it out. javapophouse.com/Datadog. All right. So with that, cheers.
Cheers.
All right. Gotta stay hydrated, right?
Mm-hmm.
All right, Tim. So tell us all about this. Where do we start? We start with Tika. We start with OpenSearch. Give us a tour.
Yeah, so the goal is to talk about OpenSearch and their neural plugin, but because I love Tika, we'll be spending the first 2 or 3 hours on that, and then at the end of that, we can break and go into a second 2 or 3 hours on Tika and files, and then maybe touch on OpenSearch towards the end. But seriously, let me share my screen. I'd like to talk a little bit about Apache Tika generally, and then Apache Tika pipes, go into some fun things that you can find in embedded files because there's just no end of fun there. And then we can go off to OpenSearch. Along the way, I'll be demoing a little GUI thing that I put together. It's not proud of it, but it's good enough for some purposes. And it's better than writing XML by hand. Off we go. Please do jump in at any time with questions.
Yeah. So Tika, so we talked a little bit about Tika on the show, and it's basically takes files and turns them into text is how I've always explained Tika. And it doesn't matter what the file is, it will find something in it that it can turn into text, metadata, etc. And it's naturally ties together with search engines, since that's what search engines tend to work with. But they don't just work with text anymore. They also work with vectors and numbers and things like that. And I know that's stuff you're going to get into later. But Tim, you're the PMC chair of Apache Tika as well.
I wanted to, like go into that.
Yeah.
Like I know you throw it in like, oh yeah, I'm at the PMC of Tika. Like that is huge, right? Like
Yeah, tell my former employers about that one. That'd be great. Yeah, I think it's awesome. Yeah, I'm thrilled. I'm thrilled that I've reached this pinnacle of Tikahood. But it's an honor to be the chair, and it's a lot of responsibility because there are trillions of files being processed around the planet every day with Apache Tika, and that's power. And I just made that number up because we have no stats. So it's not like we're phoning home. We're not XZ, for example. But anyways. Yeah, so I mean, it's a responsibility. It's a lot of fun, lots of challenges, and it's used all over the place. So yeah, thank you.
Yeah, it is one of those like little things that are, again, like it's in the back engine of a lot of systems that just nobody knows that oh, that's how that file conversion is happening. That's how that indexing is happening. It's really Apache Tika, and you know, yeah, there's a lot of responsibilities. I'm sure you watch every commit that is going through it, but I've been.
Yeah, sure. I've never merged something that had a system exit in it, I swear.
Ooh, that's for the other podcast. But
yeah, well, I am wearing my I survived T-shirt for the log for shell.
That's awesome.
For the unsung heroes, right? Like the PMCs.
Cheers.
Right. But yeah, so let's keep going. Let us know.
Okay. Yeah. So yeah, that system exit thing was exciting. I found it though by fuzzing. So fuzzing is a really neat thing. Everybody should be doing it everywhere, all the time. All right, so let me share my screen and just go over. So we've talked a little bit about what Tika does generally. What I'd like to focus on in this opening part on Tika is a module that we've built over the last like 2 or 3 years called Tika Pipes. And the goal of that is to reduce is to make it Tika more easily scalable and also more robust to problems. Let me share my screen and then off we go. So I'll share my whole screen. Let me get all my passwords out first so we can all see those.
And the credit card numbers, of course.
And the credit card numbers, yep, and all that. Okay, so good. You can see my screen.
Yep, I can see us still though, so we'll want to get rid of us. There we go.
Yeah, oh, okay. Nice.
Perfect.
Okay, so this is only it's a 643 slide deck. So let's get through this quickly.
No, it does say JPL. So I will half joke, but the other half is like, you might be serious.
It's okay. So yeah, so this was my former employer. These slides were put together and publicly released while I was working at JPL. All right, so this is like the evolution of Tika server. Like in the beginning, clients would send bytes to Tika server. And by the way, I expect this to be a deep dive. And if I'm going too deep into the weeds, let me know and I'll pull back and we'll talk about more useful stuff. Yeah. Anyways, with Tika server, clients were responsible for picking up the bytes of the file, shipping them off to the server, and then getting the text back, and then forwarding those off to Solr or OpenSearch or Elasticsearch or something. That wasn't great because you could crash Tika server, and if you didn't have your own process to monitor it, it could just die. Let me pause for a moment and say that when you're running Tika, you are running untrusted code against untrusted inputs. And that's like the matrix of joy for reliability and robustness. So over the years, we've hardened a number of things. And if you find yourself running Tika in the same JVM with anything else you care about, don't do that if you want to have anything beyond a demo. It's a really bad idea. You need to isolate the dangerous parts into another process just to make sure that if something goes wrong, you can fix it. And Tika has a number of ways of robustly handling infinite loops, memory leaks, out-of-memory errors, crashes. System exits, for example, if you accidentally put those into a parser. All right, so that was back in the day. Then we added this thing called Spawn Child, which was basically the same thing, but we set up we forked the process that did the parsing, and there was a monitor process that would restart it if something went wrong. So that was kind of the evolution of Tika server.
Like completely like spawn like new thread like new JVM or like
whole new JVM,
Yeah.
Because as you know, with threads in Java, you can't ask a thread nicely to stop within the JVM. You can be like, interrupt, and it can be like, yeah, whatevs, and just keep on going. So the only way to make it robust is an entirely separate JVM.
Yeah, I mean, a bit of history, Freddie. I mean, when you look at across the Apache ecosystem, there are a ton of projects that embed Tika into the main application for doing some of this. And it is convenient to do that sometimes, but you have to be careful because, as Tim mentioned, if you just throw anything at it and you just leave the default parser on, which will parse anything, and you throw in something bad, it's going to crash the whole application, not just the process. So this evolution of saying, hey, can we move Tika out into its own library, move it out into its own process, but then integrate the data coming out of Tika back to these other applications? It kind of sandboxes your data parsing so you don't crash the thing that's supposed to stay up and serving your customers.
Yep. And what really kind of broke my heart is I've walked into a number of client sites where they're already using Tika, and they had all their batch scripts, or major cloud companies I've seen portions of them are calling Tika Java Java dash jar Tika app on every single file individually, which is loading up a crazy amount of resources just to process a single file. So there are robust ways of dealing with it. We're trying to make them easier to use. And with Tika pipes, we can run it on the desktop or on a laptop and shared drive or something. But you can also use it through Tika server. And that's where you get both the robustness and scalability. And let me talk about both of those in Tika pipes. So anyway, so that was kind of the natural evolution of Tika server. Then in working with Nicholas DiPiazza, he was doing something like this kind of at his employer. And I was headed in this direction. Somehow we got together on this and kind of designed it together. It's effectively, on the one hand, or on the downside, we're kind of reinventing Manifold CF, another Apache project. And it's added a lot of bloat to our code base, and it requires a lot of maintenance with version updates and maintenance on that. So there are some downsides to it, but it's quite nice when you get it running. All right, so yeah, the goal is to isolate parsing into its own process. I'll skip this. We'll go through this really quickly. The notion is that we have a bunch of different fetchers and a bunch of emitters. The fetcher is the thing that goes to a file system or S3 or HTTP, pulls the bytes. Then Tika does the parsing of the file, and then the emitter is what takes that output from Tika and sends it off to OpenSearch, Solr, Elasticsearch, S3, file share, wherever you want to send it. So we have fetchers and we have emitters. I think I have this is what output can look like, and hopefully we'll get to some actual stuff live shortly. We also have metadata filters so that you can take the metadata fields that Tika calls things and kind of map them to where you want to send them in your emitter. So we can do some pre-mapping before you send it off to Elasticsearch. All right, this is what an emitter looks like for Solr. It's got a name, it's got the URL where you want to send, for your Solr instance, or your Solr cluster. It's got some other stuff in there, and there's the emitter for just file share, where you want to dump your JSON into into a file share for further processing, something like that. The fetch emit tuple has gotten a little bit has gotten more complicated over time, but the notion is I was hoping, oh, here we go. Okay, yeah. So the fetch emit tuple is the thing that the client sends to Tika server that says, here's the fetcher I want to use, here's the fetch key to get that blob, and here's the emitter that I want you to use, and I want you to call it this with the emit key. You can inject your user metadata in there. So if you have provenance data or something else, you can include that in the fetch emit tuple. That will get passed through into the emitter so that you can pass through that request and your custom metadata based on business rules. In Tika server, there are two new endpoints. One is pipes, one is async. Pipes does that process where you send it that fetch emit tuple. The server grabs those bytes, does the parsing, and then ships those off to the emitter, and will then send you a return value for success or not. Async is different. For async, it's asynchronous. You send it a list of fetch emit tuples. Tika server says, "Yep, got it," and then Tika server will run through those on its own time, so that if you are processing huge PDFs and you're running OCR and it takes 2 hours to OCR a given PDF, hopefully not that long, you don't have to keep your HTTP connection open. You've just gotten the note. Got it. I'll take care of it, and Tika server does all of the processing. There's a critical little component in there that we've added called the pipes reporter, used by async. So that is run in the JVM that's not doing the parsing, and it will output to disk or to JDBC the status of each file. So if it crashed the parsing JVM and it had to be restarted, you'll still get a note of what happened to that parse, so that you can keep good records of how the parsing went, and that's been quite useful in a number of places. All right, so those are fetchers, emitters. So with as I was saying before, with the current Tika server, the legacy Tika server, the client was responsible for getting the bytes from S3, throwing those over to Tika, getting the text back, and then throwing that out to Solr. With the fetchers and emitters, what happens is the client just sends that fetch emit tuple to a Tika server. Tika has, okay, it's not in this one. So the Tika thing is one JVM, and then each of the factories underneath it is a separate JVM. So Tika will get that fetch emit tuple, send it to one of its 4 worker JVMs. Then that worker JVM will get the bytes, do the parsing, and send that off to Solr.
Got it. So in this case, it's like you have actually split up and decouple how like Tika reads and writes too. So that's the pipes essentially.
Yeah.
Yeah. No. And now it's cool because then it doesn't matter. Like it's almost you don't even need to configure Tika, in the sense that as long as your JSON is form and you have the fetchers and emitters register on the Tika server, you can just do from whatever to whenever, right?
Yeah, no, there's a lot of configuration, right? So you have to configure the fetchers, you got to configure the emitters. It's finicky, it's not well documented. Did I mention I'm an independent consultant and can help you out with it? So there is some configuration, but once you get it up and running, yeah, it's really simple to run, and it's really robust. And you can scale it out, right? Because now you're not, if you have like an auto-scaling Kubernetes pod or pods, you don't have to worry about all of those bytes flying around your cluster, because it's really limited to what's exactly needed, and you're not doing that back and forth that we were doing before. And it's still available in the Tika endpoint.
Mm-hmm.
All right, so what happens is that if you send a file that causes a problem, and that forked worker JVM goes up, or hits an infinite loop, or crashes, or hits my system exit in the parser, it will that forked JVM will go down, but the main driver Tika server will start it back up again, and it will. If you have set up the pipes reporter, you'll get a record that this particular file caused a problem, unknown crash or whatever the problem was, or timeout.
Would it keep
like
going? We'll try to like resolve the rest of the files after.
Oh yeah. So if you send, so you can keep, as the client, you just keep sending JSON and to the async handler, and it'll just keep going through those. And with this system, it only sends one file per JVM at a time. With Tika server, traditionally, you would send a bunch of files to Tika server. They would all be getting processed in the same JVM. So you could, if the parsers weren't well written and they were available, if race conditions were available in the parser, you would encounter these. With this, you're sending a single fetch emit tuple to that worker. It does the work for that one file, and then you send another. So yeah, you send it the list, and it'll just keep going.
Yeah, Tim's talking about a lot of stuff that comes when you go beyond POC. So I mean, like, you can run Tika in a lot of environments and never hit a lot of these conditions. But, for example, Tim, for a lot of regressions for Tika, you'll run it through like the common crawl, where it's just terabytes of data, where you're going to hit some of these bad files that are going to cause bad things to happen. So, I mean, this kind of robustness only comes out of really scaling things up.
No, yeah, and
Yes.
it's interesting because the isolation level, which is per file, really, and I guess the reason is because like these parsers, right? Like they are they're just contributions, right? And somebody may just say like, oh, I need a parser for PowerPoint, right? But they might not clean up themselves after.
So we have that.
Yeah, no, the Poi project are a bunch of responsible folks. So let's not besmirch.
Okay, no,
their good name.
It was the ones that did the PDFs, right? Like,
Tim loves PDFs.
No, the PDF box folks are also really good. Sorry, we have to pick a different one.
All right, which one is left?
MP4, the MP4 for oh my gosh,
no, flash files. How about? Can we?
Yes, actually, there is a parser for flash files, Freddie.
All right. Anyways, yeah, I'm sorry.
No, I was gonna say because the interesting part in there is that even if you have a very even if your parser can parse one file, there might be state and that's I can see that, right? Like there might be state that you didn't clean up and stuff like that, and sometimes that must be the worst kind of like error that you have, which is like a file very high on the list created an issue, and then doesn't manifest itself until a way different file down on the list that you're processing runs into it, right? That is kind of like the thing that will happen if you decided to do multi-file kind of processing, right? So
yeah, if those individual parsers are not written carefully, yeah.
No, this is kind of like the iron claw of like we will make sure that every parsing that can be parsed will be parsed. Like the amount of robustness that you get on this kind of architecture, you're definitely sacrificing like performance.
Yes, absolutely.
But in the thing is, it's probably the lesser of two evils, especially now that you can horizontally scale anyways, right?
Exactly. Yeah.
Oh, that's
and so I have run regression tests. So we before we had this, we had Tika batch, which was it did that same thing that I talked about with Tika server, where it sent a bunch of parse jobs into the same JVM, and if one file caused the problem, the concurrent parses would also fail. And you wouldn't know which one caused the problem, which is, in the grand scheme of things, not awful. But for a lot of use cases, e-discovery, file forensics, other things where people really want stuff out of files, like really, that's bad. So this is why we're here. The next step is what's going to happen is we're going to we'll get the request to parse something. We'll burn it onto a disk. We will sneaker net it over to a server. We will parse the file, print it out, and then destroy the server, and then we'll have a printout. Because I think that's kind of the next level of isolation that we're going for.
Well, I think the other thing to consider is a lot of like the Tika recursive parsing, right? So where you have a file that has images in it, so you parse the file, then you need to parse the image, and maybe you're doing OCR on the image. Like Tika will recursively go through and take it all the way to that nth degree. Even with the file-based isolation, I'm guessing when you recursively parse, that's still in the same system. Yeah. So if something inside your file causes that error, the entire recursive nature kind of blows up on that subsegment. So
absolutely, yep. Yeah, that's still a thing. But I'll show you some ways of getting around that. Cool. Where you, anyways, yep.
Yeah, let's keep going. Let's keep going. So, I mean, we've hit on the robustness. So, I mean, the main thing that we've conveyed here, I think, Tika is very robust at parsing files, and it's often ignored because until you start parsing a lot of files and a lot of potentially unscanned files, maybe where you don't know what's in everything, you don't hit a lot of these use cases. But let's start moving into the search the search space from this. So you've got this process, this robust process that I can send files to. It's going to take those files and it's going to emit it into a service that I can then do processing and retrieval off of. Yep. So, how do we get, so once it's out of the Tika piece and starting to go into the search piece, like walk me through what are some of the steps
Sure. So
that happens afterwards.
Before we get there, I just want to finish out on the scaling, which is
sure.
So now you can set up a bunch of different Tika clusters. The client just sends the JSON to those various clusters. All of the processing happens, where it should, and you can, overwhelm Solr, which brings us into search. So thank you. All right. So I'm not sure where the next thing to go. Before we get into search, I would like to hit attachments a little bit. So let's do this. So just for kicks, a fun thing with incremental updates, PDFs can have incremental updates, which means that you can recover earlier versions of a PDF. We've made this now default with the -Z option, and I will get to search, I swear. So the input PDF looks like this. It has testing incremental in this black image. And with this thing, you can reconstruct the earlier versions of that PDF. So this was the first version of the PDF. This was the second version of the PDF. And you saw the final one. And as Bob said, it also pulls out images. Well, that's a boring image, but it's an image. And there's some other fun things that it will pull out. So yeah, there's a lot of good stuff there. There's one other incremental or one other embedded story that I'd like to share with you. Let's do this. Java dash jar. Where are we? Do we have an app in here? Yes. Okay, we do. Okay, so bin Tika app -J capital J dash T input 9 something. Or 2.6, okay, into 261.json. All right, so this is going through a PowerPoint presentation, which looks completely innocuous.
If you're sharing?
Hey, Tim, are you on a different workstation maybe?
No, I am not.
I heard you verbally talking through it, but I don't see I didn't see a terminal or anything else, so that's why I bring it up.
Let me reshare.
Sure.
Can you see my screen now?
It is still starting for me.
And has started.
Starting to share. So,
do you see?
Yeah. So let's talk a little bit about the versioning piece that you were talking about while that's still loading. So where you have, you had testing and then another test and then an image in all coming from the same PDF where it was maybe different edits to that PDF. Yep. Is that like, so walk me through what that would look like in Tika, because I know Tika has the breakout where it'll give you content and then it'll give you metadata. Is it attaching metadata? Is that 3 different content files? How does that output in Tika? Because that's actually a piece that I haven't messed around with very much.
Yeah, so because it's, can you see my screen yet?
Yeah, I guess.
So I don't know if you want to try sharing one more time while you're talking through that, but for whatever reason, it's struggling.
Let's try something smaller then. Let's try this. Let's try a single window. Any luck?
It is definitely the year of Ubuntu on the desktop. No, it's not there yet.
Anyways, so when that comes up, what happens is when that's configured, we have what I can see on my screen is the output is a JSON file. It's a list of JSON objects. Each object is a sub either the container file or a list of sub files, and each object has a key and metadata. And that one of those keys is content, so you get the full text content as well. So what happens
You're back also.
Oh, awesome, thank you. So now you can actually see. So this is the PowerPoint, and you can see that we're in the land of JSON array, and here's the the object for the container file for the main PowerPoint thing. We have a bunch of metadata. We have the actual content from that PowerPoint presentation.
Wow.
And then we should have some other embedded files. Yeah, so this is, yeah, so this is the main PowerPoint. And then look, there's a Visio file in here. This caused a runtime exception, which was caught as it should have been. And that is here, embedded path ID. So that's under the main file. There's another Visio thing that's causing problems. So this is just, so these are all of the embedded files, JPEGs, all sorts of crazy things are in here. So when Tika is configured to extract earlier versions of the PDF, those show up as if they were attachments, but the attachment type is version or something like that, instead of attachment type being attachment or embedded file type, I think it is.
Yep,
Oh, wow.
that makes sense.
That's crazy. So not just that it gets the PDF, but it essentially then will create a version on each particular iteration of that the PDF has history of.
Yeah, and the way that PDF can store versioning with incremental updates is, if you have your base PDF, if you make modifications to it, it will take the end of file marker from the original one and just put the new data at the end. And then if you modify it, it'll put the new data at the end. So all you have to do is back off and truncate the file from the end to those earlier EOF, end of file markers, and you have the earlier PDF, which is just absolutely shocking.
Yeah.
For people,
don't put anything on the PDF that you don't want to, even if you delete it.
Yeah, or even if you do, don't put it in PDF.
Will find it.
So, but we also maintain the embedded resource path. So even though we have a list of files, you can reconstruct that there is this embedded PowerPoint presentation within this PowerPoint presentation, and it has an embedded file within it. It's an unnamed file. It's like a JPEG or something like that. PNG. So there's an embedded PowerPoint presentation inside this PowerPoint presentation. Okay, that gets interesting.
Wow.
So it's just this amazing combination of files. And let me, anyways, yeah, so I'll stop on there because we need to get.
No, I mean, that's definitely one of the spots where, when people ask, well, why use Tika? Because, hey, I only need a parser to do X, Y, and Z, the robustness from being able to handle some of those malicious things that people will do, to just being able to recursively go through a file and get the maximum amount of information out. Most parsers aren't really set up to do that. They're really just single utility items, and Tika is the tool that just kind of brings it all together.
Yeah, absolutely. And I can't emphasize that enough, because, so often what I'm seeing in a number of these demo things for retrieval augmented generation or hybrid search or vector search, is somebody runs PDF to text on a PDF and they're like, oh, look what we did. And it's like, well, yeah, but that could have attachments in it. So you can't run PDF to text against a PDF and be done with it, because it could have a Word file in it, it could have an RTF file in it, it could have another PDF file in it, and you have to recursively go through all of those to get that content. And the thing is that Tika we have a bunch of parsers, but it's also a framework, so that if you really like the text that you're getting from PDF to text, we have a wrapper for that outside of the project, but I can give you the wrapper that will run PDF to text if you really like that text. Or if you have another Python thing that you really love, we can run that in the Tika framework, and you will still get the benefits of being able to parse all of those files recursively. Yep. I have a scare presentation that will cause anybody who's concerned about PII or any other sensitive stuff about all of the crazy file formats that you can stick inside of other file formats. You can put binaries inside of TIFFs. You can put binaries inside of HTMLs. And pretty much, unless it's a text file, and it's a text file, like it's actually a text file, not just it ends in .txt, it can have an embedded file. And if your parser's not set up with this whole host of parsers to be able to handle all of that stuff recursively, you could miss out on a lot of stuff. In the e-discovery case, for example, if you're not doing it well, the opposing team could get a lot more data out of those files than you get. In forensics land, that can also be a major problem if you're missing stuff. So it's really important to have all of this stuff together and not just, here's a PDF, I'm going to run my PDF thing. Oh, look, it has a Word file in it. Now let me run my Word file thing on that embedded
Right.
file, right? Like don't do that. Either use Tika or reinvent it somehow, I guess, because that whole thing has to be together to work together.
Right. Yep.
All right, so now I'm going to try to share the whole screen.
You can see the wheels turning with Freddie now. It's like, okay, yeah, this could be fun.
Like I'm just thinking, the thing that I'm coming back to was like when they released the redacted statements on like core filings, and you're wondering how they did that. Like, oh, I just took the PDF and now I put the black text on top of it, and then right, and then you're like,
not to Tika. Yeah, exactly. Black text. Oh, we're just gonna go around that image and pull out the real stuff.
Oh my gosh, yeah, no,
from the previous version.
No, just go to the previous version. Like there is so like my mind is blown of the possibilities. Like,
oh, let me just tell you,
why
the world
Tika and the
really...
Panama Papers were a thing, right? So
yeah. I mean, let me just say the world is a fun place.
Oh, we can see all your stuff now. Yeah.
No,
okay,
it's all good. So,
all
right.
All
so
right,
where do we go from here, Tim?
We can't move on. I've got to show you the punchline here. All right. So this is the embedded file. So what I was showing you was a Department of Interior publicly available slide deck from GovDocs1. Inside of it is a contractor slide deck. It's like a 3 meg.
It's like an Easter egg for your,
Yeah.
Tim, are you going to start embedding your contact information in these things?
Oh my.
Who knows? But seriously, like, so this is a 4 meg contractor deck stuck inside this Department of Interior deck. And what's amazing about this is that you can't actually find this file with PowerPoint anymore. It's stored in the file, but you can't get to it. So this was the slide that I was like, wow, you really might actually really care about those things that are embedded in files, wouldn't you?
Wow!
This is a contractor deck stuck inside of an official Department of Interior deck.
Nobody can get in trouble. This is publicly available information, right?
It's publicly available.
Oh my gosh, this is insane.
But and the crazy thing is, when you think about, to tie it back to the AI piece, people talk about, well, we're training our models on different things, and if you're adding files to those models and there's things in those files that you can't see that the model is using, like that is going to change how your model interacts with the next piece of data it sees after you retrain it on that. So I mean, like, these things do matter.
Oh my gosh. Yeah. If you're trying to train, like, can you imagine that? Like you have like malicious embeddings in some training for like your LLM or damn, yeah.
Yeah. Anyway, so I've found it. So anyways, to get back to that one little story, you can no longer, with the PowerPoint application, you cannot find that embedded file anymore. It's stored in there, and Apache Poya is able to find it, but it doesn't have a link to anything in the file anymore, but it's still in the embedded file storage section within that file. And I only found it because we started scouring the files for attachments that didn't have a link to them anymore, and we started pulling them out. And then, as Bob said, we have this million file regression test out of Common Crawl. So we ran it against that and said, oh, look, we have more attachments in this one file. Whatever did we find? And I found that. I was like,
oh my gosh. And I wonder how it got there. Like I don't like it might not have been malicious. It was just like, oh, we had this embedding. They deleted the link, and PowerPoint just didn't clean it up from its file, so it just kept it there.
Yep. Yeah. Who knows? Yep. Who knows? Who knows? All right. Are you able to see my screen?
Yep. Yes. Everything's working now, Tim. So okay. Fire away.
All right. So this is a little app I wrote. I don't encourage anybody to use it ever.
JavaFX, right? Freddie, you know something about that.
Oh, this brings me back. Oh,
I know. Isn't that fun?
Yes.
A-
Yes.
Anyways, yeah, it's a thing. This should be working. Okay, yeah, so it's actually, it took a while to kick off. Okay, so what's happening is this is pretty much, as I said, a way to write XML, or it's something that makes it a little bit easier to write the XML, because getting Tika to configure stuff is can be challenging. And I am getting to OpenSearch, I swear. What with the output, so this is input is file system, output is file system. So it's just writing all of these JSON output files to the directory.
Right.
I have one person I'm working near does this, and then they want to do their own custom Python stuff on the JSON, but this at least gives them a robust way of getting that JSON multi-threaded, multiple JVM'd, isolated, and all of that other good stuff with Tika pipes. So that's file share to file share. But the other thing, of course, you can do is you can send it to other things. So another group I'm working with really likes CSVs, fine, whatever. So the way that works is that you select the metadata mappings that you want. So I have those here, default metadata mappings. So what this is, it's just a CSV file that says, if Tika calls it this, I want it to call it this in my CSV file,
Okay.
right? So it's just those mappings, and then we can, it'll write to Tika extracts. We have to choose the directory. Let's put it on the desktop, open, validate, okay, and then run. And then Tika pipes is running. It's extracting that information. In that mapped metadata, we did not include the actual text of those files with the content because it's so large. For some people, they don't want the content. They really just want that metadata. They want to know, when it was created, what the file format was, who created it, what the creator tool was, that kind of stuff. They don't actually want the content. So dumping to CSV is kind of for them. This is running to, I think, a H2 database. And then it takes the H2, it does a join, and then writes that CSV file. So now we have the Tika extracts file that was written out. This also does a join on that status table, though. So if there was a crash in that status, you would have timed out OOM and so on. So this is so these are all the input files. Those are SHA-256, the name of the file, and so on.
Yeah, this is fun. You're taking some unstructured data and you're creating some structure around it. You still have the unstructured content, but again, you're
structured metadata. You can actually do a lot with this.
Yeah.
Yeah. So, so this is one of my favorite files. So this Agora Web, while we're at it, because I will get to search, I swear. All right. So part of the challenge of if only there was some way to search. Okay, so this little app that I have also runs language detection, and it runs a statistic we call out of vocabulary.
Yep.
And we built that into Tika eval to kind of to be a junk detector, so that we could find bad PDFs or PDFs that have unreliable text in them, and or HTML files where the encoding gets wrong and you get complete junk. So out of vocabulary, the way that works is we run language detection and we say, okay, so this is identified as Bihari. Well, we have a list of the top 20,000 most common words for Bihari. So how many words are actually Bihari in there? This says 100% of the words in that allegedly Bihari document are not Bihari. So that means that it's like totally, totally junk. So if you look in the output for that file, I said, when you look in the output for that file, what was, here we go.
Yep.
And open it, you can see that the text is in fact junk. And operationally, this is critical for a number of things. One is if you're running on a search system, you can say, if our out of vocabulary is above such and such, run OCR on it, because the PDF renders just fine. It's just the underlying electronic text is complete junk. Where this gets really dangerous, or where this is really important, is if you're doing cross-domain transfer and you're moving from a highly secure area to a lower secure area, and you're running dirty words lists looking for like classification labels or something. If this is the text you're pulling out of that file, and you say
it's going to pass,
does it say it's classified?
Nope.
Yeah, doesn't say it's classified. All good.
It's fine.
Right? It's totally fine. So that out of vocabulary thing is useful for regular search systems. But the more important your text is, and the more important to get the text right out is really important.
Yeah.
The other thing that we have in here is within PDFs, you can keep track of how many characters on a page do not have Unicode mappings. And you can see here that there are 4,000 characters on the first page. Same number of characters are also unmapped. That's typically a sign that something has gone horribly wrong with that PDF. It's another signal that you better run OCR on that PDF.
Yeah, and this is huge. Again, back to, I mean, even to tie it into your language your models that you're training with this data. Again, your models are only as good as the data you feed to it. So having a process in front to be able to gate that and say, you know what, we are looked at this file. This is all garbage. This is actually going to create more noise in our model. That's really important, right? So I mean, and the other parsers that you might look at that do one thing well, they don't have that, right?
Yeah. It's interesting because and
this Tika eval thing is.
No, go ahead.
Oh, sorry. Anyways, yeah. So this thing is really important. It's useful in a bunch of different use cases. All right, so that's the CSV output. Let us now go into what we came here for, which is Tika. No, OpenSearch. Sorry. All right, so anyways, quickly, let me just show you. So basically what this application is doing is, so I think I'm running it out of here. Yes, I am. All right. I thought I was. Modified. Yeah, okay. Yeah, that's the one.
A lot of Tika configs.
All right, so pretty much what this app is doing is it's taking my interaction with the GUI and generating the Tika, the Tika config file. So here are the metadata filters. Here's that mapping. Remember how we loaded that CSV file into the app? The way that you would represent that in a Tika config file is here. So this is using the field mapping metadata filter. So it's saying, if it's this in Tika, write it out as that. This is the pipes iterator, which says, go through, iterate through all the files in this directory. We also have S3 iterators. We have Solar iterator. We have a bunch of different iterators that will programmatically go through data stores and pull out those effectively the keys for that fetching that tuple. Then we have the JDBC emitter. This is what to write the CSV file. As I said, we store it initially in a little H2 database, and then we do a join to get that final CSV file. So this is, again, auto-generated Tika config file for what that config looks like to get it working. Here's some stuff for running async stuff, configurations for the auto-detect parser. So it's extraordinary. It's really complicated, and it's hard to get it right. But with this GUI, you can at least get started, and then you can start modifying manually if the GUI doesn't have everything, but it at least gets you started on a bunch of stuff that's kind of useful. So it really is just an automated or a way to write an XML file.
Did Tim mention he's an independent and he's available for consulting on this?
Yeah, I like to spend my time helping people, not documenting.
Cheers.
All right.
No, wonderful. Keep going.
All right. So now we go to the OpenSearch, but before we go to no, I'm joking. We'll go to OpenSearch now. So we also have JDBC, so you can write your stuff to JDBC too as well. Okay. So now for OpenSearch. So I did the basic Docker Compose OpenSearch most recent. Got the I want to say Kibana. That's all right. Dashboards working, and I'll show you what that looks like. But the workflow is the same as the CSV. You have to load metadata mapping thing. In part of I have that. So let's load that up. So we have those. So take this and put it into that, and then you just do your usual OpenSearch URL. Let me see if I can get this right.
Yeah, and the reason the mapping is important is because when you think of your search terms and your search queries, you don't want to have Tika colon and things like that in there to map it to something a little bit more concise is going to help your querying and extraction. So
yeah,
that makes a lot of sense.
And the other big problem with Tika, or it's a challenge with it's a reality challenge. It's not a Tika challenge. Tika has its own challenges, but this is a reality challenge. Is that the metadata keys are an open set because there are custom metadata keys within these files. Tika want to pull those out. So now you can have 2 million different keys, right? So you don't want to stuff an OpenSearch index with 2 million different keys. You really have to. So when you load that metadata, it automatically says it's not just mapping those including everything else. It only includes those ones that are mapped, so that you know that you have a limited subset of those, so that you don't blow out your index. Speaking of which, the other thing that OOV is really important for is you don't want to put all of that junk in your index. You know, you're not going to get false positives with it, let me tell you that, but you also don't want to have all of that high entropy data getting stuck into your index, because that'll blow out. I mean, like Lucine's amazing. You're not going to destroy Lucene with some bad PDFs. Well, you could.
But your relevance might go down, right? You might not get the accuracy that you want.
I
get false hits.
with junk, not so much, because junk is junk and you're not going to confuse it with stuff. The larger problem is that your index will if you have an individual, you know, for postings, you know, for each word, you're going to have a much larger index than you would need. And nobody's ever going to search for all that junk, right? Because it's
okay. So inefficient storage and okay.
Okay, so let's just make up a new index. We'll call it that. We'll hit update and let's run it. Let's go over to not this one. Let's go over to this one. All right, and let's hope everything is actually on and working. CAD indices. Okay, so one. I thought it was here. Tika basic.
Tika 1, 2, right? Or
do you see it?
I'm trying to. I don't see it yet. My eyeballs have not adjusted.
Patience. We need patience. That's looking promising.
Yeah, it looks like it's almost done.
All right. Let's go back.
Maybe it just needs a little refresh.
Okay, so we'll close that out. Oops. Well, that's not what I wanted to do. Okay. Let's try that again.
All right, there we go.
Okay. There we go. Tika 1, 2.
Yeah, there it is. Yep, I see it now.
Okay. Okay, so that is the index. It has 276 documents. Right, we have replication, so it's the actual is twice as big as a single index.
Yep.
And we can search on it, right? So we can get. And that is with the schemaless index, right? Which don't ever do that in production. But so it goes.
You've done everything else right, Tim. Like you still have security and everything else enabled. So you're still a step ahead. Like my first thing whenever I set up OpenSearch, it's like, okay, disable security plugin, single instance cluster. It's like, no, you still have a cluster with security running. So you get extra credit for that.
Yeah. Anyways, yeah. So this is it, right? And those are some large PDFs. So you know, it's a lot of data in here. Like it's a lot of data.
Yeah.
Which brings me to the other stuff. All right. So that's kind of what. So what that will get you is that XML file, and now you can put those XML files with Tika servers on a bunch of different pods and blast a bunch of, you have to write, I'm working on the client that will do this, but you can write your own client pretty easily. It will just blast all those over to the Tika servers, and then it'll dump all of the extracted stuff into OpenSearch.
Interesting.
So
now you're finally at a place where you can use your models and you can use search and extraction and do some fun stuff.
Fun stuff indeed, but not yet, because the big problem, or one of the challenges with the LLMs, is that there are limited context windows. So if you have a 700-page PDF, you have to chunk it into like 2,000 word, 5,000 word, depending on your model, context chunks. And what's hilarious to me is that naturally will get you better search results. It'll get you better snippeting. It'll get you better relevance. It'll do all these things for you if you're dealing with a bunch of PDFs. And I forgot to show you this batch of files is largely, it's pretty lengthy PDFs.
Yep.
So now with the advent of LLMs and RAG and hybrid search and all that other stuff, all of these tools are now doing this chunking of documents so that they can get the LLMs to work. And meanwhile, and also, that would have been great with just traditional search, and is a really enabling step, even if you don't turn on vector search, because it could be expensive, for example. So that's what it looks like to get old school documents into old school OpenSearch, and there's effectively no length limit on that. You have, before you do that nowadays, though, if you were going to run a vector model, you have to figure out what the context length is for your model, and then you have to chunk your documents, and that's where Tika needs some help. We do not have chunking built into it, but a bunch of the other tools do. The other area where Tika needs to get better, it can get better. This is where commercial tools are probably going to be doing much better, at least in the near term. Is right now, some chunkers just take the full string of the document and just say, token 0 through 100, token
substring.
Yeah, seriously, it's just substrings, and sometimes in some you can choose overlap, which makes sense, and then at retrieval time, you just have to figure out which, if you have overlapping things, which one has a higher score, and so you're not showing users duplicate stuff, or you're somehow aggregating those scores from the component pieces. So that means that your framework gets a lot more complicated. And I've even seen a hierarchical thing where, and this is all built into like LangChain and some other stuff, I think, Haystack, is that with hierarchical chunking, so you chunk it into like sentences or sentence-like things, and then you have paragraph level things, then you have like page level things, right?
Yeah.
So, but managing all of that in reasoning over that and getting relevance over that is interesting. Mm-hmm. So anyways, so for the demo that I have here, I literally just took the strings and chunked them up. Where I was going though was with GoString. With Tika, where we want to be heading, and I'm hoping that companies like Unstructured.io and Datavolo, I hope I got the pronunciation right, are headed. And the cloud offerings are there somewhat now too, is to do better document understanding so that you can put that cow back together from the hamburger of the PDF, and that's not original, that's an old saying, so that you pull out logical paragraphs, because NLP was always totally hosed by word super PDFs. It's the same problem for LLMs, that if you just take the full string and you get words all over the place, it's not going to be as useful for LLMs. So document zoning is one area where I think Tika could be doing a better job, and I think the commercial industry is going to be doing a lot better near term on that, so that you're doing smart chunking. You're not just taking the string and breaking it up. All right, so the demo that I have is built entirely from Opster, and I'll send you the link. It has to go in the show notes because I stole this demo straight from them. They have a really good demo. Opster, SEAS, SEASE, a bunch of great folks there. And also, of course, OpenSearch have really good tutorials on getting stuff running. So basically, you have to do some stuff to your cluster to make sure that it works nowadays. You have to pick a model. This is the mini LM, which is good enough for demo. You have to set it up. You have to set the model up. It's the embeddings pipeline. The embeddings pipeline is the thing that says, here's a document, take the content field and put the embedding into a field called content neural. I just made that up. But it's the thing that says, take the incoming field that's named this, create the embeddings for that field and call it this. The other thing is that you need to set up a search pipeline, and what this does, at least for hybrid search, so what this specifies is you're searching both, you're getting results from both traditional TF-IDF old school vector search or regular index search, and then also from neural. And this is saying weight the first one 40% and weight the second one 60%. There are a bunch of other techniques for merging those things.
You get 2 scores and
And then to create the index, so this is creating the Tika neural index. You have to tell it that you want k-nearest neighbors available, and you have to tell it what the pipeline is for putting stuff in there, so that so that when you're sending stuff with a content field, it knows that that's text, and it knows that that content neural field is going to be a KNN vector. You have to get the dimensions. Those dimensions have to match your model that you loaded up earlier. And then you got your what type of method you're using for similarity. Here we're using Lucene. We're not using the external Facebook face tool, and we have the hierarchical neighbor thing going on there.
Yeah, and just to dig into the embeddings piece, I mean, when you talk about taking text and turning it into embeddings, you're talking about turning the text into a vector, right? You're talking about turning it into numbers.
Yes, and let me show you what that exactly looks like. And
if you're using the same model to do the embeddings, like it should have the same number of dimensions, because everything's kind of, you know, you're kind of centering this around the model that you're using.
Exactly right. So you give it that model, and at index time, it will take that content thing and create the embeddings field. So this is what an embeddings field looks like, right? It's just a bunch of floats for this thing. So it's taking the text from this chunk of text and creating just an array, a vector of numbers. So that then when it's doing that similarity, so the content is configuration of samples 18C33, blah, blah, blah. It has used that model and created this vector. Now, back in the day, before this was all built in, you had to do this all manually, but fortunately, Elasticsearch and OpenSearch in different ways now have the, OpenSearch at least has this neural thing, so you can just send it, you specify the model and tell it to do those embeddings for you, so you don't have to do it outside of OpenSearch, which is really nice.
Yep.
So yeah, so that's the vector representation. So then when you search on it, so here's an old school search for just documents that contain nitrogen. It will give you documents that contain the word nitrogen in them. Or if you want to say, what is a leak test, and you want to search on the neural component on those embeddings, this is what that query looks like. And the query text is, what is a leak test? And it brings back documents that will tell you what a leak test is. And it's creating that vector, the embeddings at index time for those documents. And then at search time, it is also converting that text into an embedding. And then it's doing the vector math to find the closest matches.
Yeah, the text meaning the query text. So it's taking the query text, it's creating a vector out of it, and then it's finding the most similar retrieval to that vector using the algorithm that you selected.
Yep.
Yeah.
Exactly right. Yep. But okay, so you can launch a traditional query against the content field. You can launch the neural query against the neural field. And here's what the hybrid looks like. Hybrid search looks like. You have to specify which pipeline you're using, because remember, with that in that query pipeline, we said that we're having a couple of different searches, and we told it what weights we wanted to apply to each. So for this one, we're saying do a hybrid query. The first query is a traditional match query, and find things that have the word nitrogen, excuse me, and then also do a neural query, and also find things that are kind of like nitrogen in this vector space. And when you run this, you get stuff, some of which don't even have the word nitrogen in them, which is kind of fun. Like that's what you want, right?
For a neural search, yeah, absolutely, yeah. Right. But yeah, your typical match is going to look for that word in the index, and it's going to only give you stuff with that word. Neural can go a different direction. Yep.
Yep, and that's the whole point of neural. And I mean, the basic takeaway from every conference I've been to, let me put in a plug for the Haystack conference that's coming up in April, run by Open Source Connections. It's an amazing conference. Berlin Buzzwords is another great search conference. And then there are a couple of e-commerce things kind of around Berlin Buzzwords that can also be really good. Mices, nice conference. Anyways, yeah. So that vector space will bring you back documents that don't even contain your keyword, which is great from a recall perspective because you'll get documents that are similar to what you want. But from a precision perspective, it can also bring back junk if your model isn't fitting your documents well, your particular documents well, or if there are other things that happen. So it's important to get hybrid search so that you have kind of the best of both worlds. This method of saying 60% for this and 40% for that is a good first step. There are much better ways of doing that, and I think they're only just starting to be built into OpenSearch. There's it's like I think it's a mean rank something or other. So you pretty much take the top 100 results from both, and then you figure out what the mean rank is for each one, and sum those effectively, or take the mean for the ranks for those documents. So it's a different way of bringing together the results from those two separate queries and infusing them into something useful. Yeah. Okay.
Yeah. So this is amazing.
Yeah. No,
Yeah.
go ahead.
What's just so amazing to me is how far OpenSearch and a bunch of other vendors have come in the last year or two. I mean, to do this 2 years ago, you had to break out your own scripting stuff and do your own embedding stuff, send off the things, and it was just a mess. This is straightforward, and I do have to put a plug-in for LangChain and Haystack. They both wrap OpenSearch as data stores, and they take care of a lot of stuff for you. The reason that I'm working on at this level is because those things are great to get going, and they'll probably be good enough for production, probably. But there's so much nuance to getting stuff working in OpenSearch that they kind of make easy for you, that actually getting it running in OpenSearch or in Pinecone or in Vespa or in any of the other vector search engines is really a useful exercise, especially as you want to scale it out and start tweaking stuff and playing with stuff, because the packages don't make all of those bells and whistles easy to get to. It's all documented. You can all look into it, but I find it really helpful to go to the actual thing and get it going here. Still use LangChain, Haystack, and so on, because they're just really amazing packages for doing RAG, doing this hybrid retrieval, and a bunch of other stuff. All right. Let me go over a couple of I guess we have to wrap up pretty quickly, but let me go over one thing that's really a challenge. So just a couple of other things about neural search. So the thing about with keyword search, you know how many documents have your term. So you can give a results and say, hit 2 million documents in your document set, right? With neural search, it's infinite, right? Like all of the documents are kind of similar because it's all in vector space, right? So you have to tell it how many documents you want it to bring back, which is a completely different paradigm. And if you're only doing neural search, you actually don't know how many documents have a hit, because what really is a hit anyways? Everything's a hit, but some are more than others. So you have to have some way of thresholding it. The current way to do it in OpenSearch is you just say, give me, 5 or 10 or 100, or however many. You give it a number of documents, and it will bring back the top 100 or whatever of those. So here, what we're doing is we're saying, I only want the top 3 neural documents, but I want a total of 10. Right, so it will do the top 3 neural and kind of insert those, or fold those into the top 10 results. I don't think that's a great choice at all, but I just wanted to raise that.
Well, let's talk about that a little bit. So I mean, within neural search, so you're doing a k-mean, so you're getting basically a distance, right, of how far away this vector is from that vector. I mean, again, simplifying. So there is sort of a score involved here with to say that, hey, this is really, really close. This is probably something you want. So if you set the document size, you don't really know, well, was I close or not? Is that represented in the score in the neural search that, hey, I got the top 3, but these documents kind of were really far away, so they kind of actually suck. But
it is. We're wrapping up. I don't have time to show you, but
that's okay. Let's talk through it. Just talk it.
So OpenSearch and Elasticsearch and Solr have an explain function, which will give you. Well, no, I mean, look, you can see the score here, right?
Yeah, that's what I'm trying to get at.
Yeah, so it's there. The thing is that it's not showing you what the neural score is versus the regular score. It's bringing those together for you. So you may have to write your own handler, right? So instead of this. This thing, it's possible that you can probably write your own search pipeline that includes both of those scores, or does some kind of looks for that curve of relevance and says, if the curve drops off, then stop cutting. The current thing that's built in, that's easy to get to, that's on Opster's demo is top N, and that's not great, but it's easy, right?
Yeah.
But there are definitely more useful way or more complex ways of doing that. And again, that relevance curve is going to be really important. So that if the curve looks like this, well, then take all of those documents. But if it goes like that, then stop there, right? And you can. So yes, and the other vector search engines might have that built in. I'm not sure.
Yep. No, that's super useful. Yeah, no, this is great, Tim. I mean, we covered a lot of ground within our hour here, going from Tika, pulling the documents in, getting them into the search, which again, like, you kept saying, hey, we're gonna get to solar, but that really is half, probably 75% of the battle is how do you get good data into the search engine, and then once you have quality data, the search relevance and that all kicks in because you started with good data versus starting with crap. And it doesn't matter what algorithm you're using, you're going to get crap in, crap out.
Yeah. And quickly before I let pass the baton back to you, Freddie, sorry. What I haven't covered at all is how you measure relevance, right? And that's a whole other hour.
That could be part two.
My contact information, but I've just shown you kind of the basics and how to get stuff set up. But to twiddle stuff and to fix stuff, is a whole other thing. Sorry, Freddie, go for it.
Amazing. And if you want to get to this before, Tim has a rate and a phone number that you can call. So this,
which is I know, right? In this video somewhere, but you need to use Tika to fetch it out.
To extract.
Oh, that would be amazing. Like
I'll just send you an XZ file. I'll let you know.
Yeah, there you go.
Open up that XZ file and I'll be great.
No, but the thing is like just so like you get the context of we've been kind of like going into the trees, right? But like for the forest is like you can really like if you have a corpus of text, be this like the easiest one, emails, but let's say that your customers or you have a website where you're collecting like information about rates or comments or stuff like that, and something that produces a corpus, and you have it stored somewhere in free form across, right? It could have been email attachments, it could have been just like people writing on this particular thing. There's an incredibly easy system that is open source that first can slurp that in, then and you can feed it to another open source system where you can actually then essentially vectorize it, qualify it, and be able to search. And not just that, you can actually search it in two different ways. One of them is just your regular, like similarity search, vector search, and your other one is using like KNN, which is more of doing this kind of like tokenization and neural networks for figuring out similarity in documents. And all this you can do I'm not saying it's going to be like a day worth of work, but it's relatively easy to do now compared to if you needed to do like 2 PhDs on like a game theory and vector theory just to like try to do these things. And that is kind of like the power that we have with this, which is, there was now a set of problems that maybe you didn't know you have that now are just, that are really within reach, right? Like all the stuff that we covered today, it allows you to like help and qualify all these unstructured information you have. Go, Tim.
Yes, and of course, I just showed you how to throw stuff into an engine and get stuff out. It can still be a bunch of crap and it does require some pretty good skills to do the tuning, right?
Yeah. No, don't just point it to something and then hope for the best, right? Like, yeah, there's still science in it, but at least it's not as. At least the ladder is not the technological ladder of I need to get assistant to get these things in. Now it's more of like you spend more time actually doing the how do I get real good data, right? And then like and even then you like Tika has those levers that I never thought about, like just figuring out language correlation for are you actually getting crap, and like all that actually like is helping you fight that and helping it make it easier to distinguish like bad data. No, it's super impressive stuff.
Well, thank you both so much. I've had a great time talking, and I really enjoy hearing myself talk. So, anyways, forgive me for blathering for so long.
No, Tim, this is a great episode. Like I said, we've dabbled in search, we've dabbled in Tika, but this is a cross section that we haven't touched on and is completely new. And again, like you're a Java developer trying to figure out your place in this AI world, and everybody's talking about Python. Like, look at all the JVM tools that are out there that you can be using to do AI work. You can integrate to models, you can do search, you can tear documents apart and turn them in. And all of that is for you, the Java developer. Python doesn't have that quite yet. It has the models, it has the training, it has Hugging Face, but still some amazing stuff you can do on the JVM. So thank you, Tim, for sharing all this. And it does sound like we may have to do another episode on Relevance. So
yeah, that would be amazing.
More to talk about.
Yeah. Yep, Tika Part 2 and Relevance.
All right. Well, I guess that's it for our episode today. And like every other episode, thank you, Tim, for being with us today and sharing all this incredible stuff. We'll put a lot of links on the show notes for like those who wants to keep following through. And Tim is like he said, he is available for consulting. So, please reach out. This is Freddie signing off.
I'm signing off.
And I guess thank you.
All right, thank you. Yay! We did it!
All right. See, that was easy.